We're still waiting for Tom, but while we are, just to show you, I'm going to run it. And what it said was if you had a GPA that was less than 3, okay, and you had a score that was greater than or equal to 80, you were accepted. Notice if it's less than 80, you're rejected. If you've got a GPA of 3 or above and your score is 60 or above, you're accepted. But if it's less, you're rejected. So it does work. All right, that's the key thing. All right, so I gave you 2 handouts. All right, they were on your desk when you walked in here this morning. So I'd like to go over both of those. Chapter 5 is on looping. Looping is the idea that you can run a block of code as many times as you want to. So to show you it in its most simplest form, when I run this program, which is just a console program, notice what I get. It does a while loop and it prints out the numbers 1 to 10. Then it does what's called a do while loop and it prints out the numbers 1 to 10. Then it does what's called a for loop and it prints out the numbers 1 to 10. All right, this is to show you that quite often when you run a loop, it doesn't matter which loop you use. All right, are there ever times it does? Yeah, we'll go over that in just a second. All right, now I don't expect this totally to make sense to you, but if it doesn't, I'd say a good place to start would be to read the chapter. All right. The while loop, which is what we're going to look at first, right here. This is the code. It's called a pretest loop. We may have gone over this last semester. Can somebody answer me this question? If I do this, if I make that 11 right there, how many times is this loop going to run? You're not in this class. Okay, yes, why? Yeah, because 11 is not less than 10. Just to prove it, if I come in here, put that in, and then run the program, there is no output. And we just get the read line, then it does the other two. All right, it's called a pretest loop. And the pretest means that you make the determination of whether or not that's true before you go into the body of the loop. The body of the loop is what's in the curly braces. All right, I like to use LCV. You don't have to use that. This is considered the only acceptable time to use things like IJK, etc. for names. I use LCV because LCV stands for loop control variable. If you like that, use it. If you don't, use whatever you want. But this is saying, okay, I've got a variable that's called LCV that I'm setting equal to 1. As long as that variable is less than 10, add 1 to it and print out the results. In fact, that should be 0. All right? There's a shortcut way you can do this, and I show it right there. We could have said, instead of saying this line here that you see on the screen in blue, and I don't think it'll let me highlight 2 lines, and that line, instead of putting in these 2 lines, I could have put in this, while plus plus LCV. Most people write it like this because it's a little easier to read and understand. All right? This just says as long as my variable is less than 10, print it out. Tab 1, tab 2, tab 3, tab 4, right here. All right? And every time you print it out, before you do, add 1 to that variable. That's all it is. Then we have what's called a do-while loop. All right? In many ways, it's kind of the opposite of a while loop, because the do-while loop is post-test. If you want to make sure your code runs at least one time, all right, you put it in a do-while loop. Because notice, you don't make the check until the end of the loop. All right, so you always run through the loop at least once. So if I came in here and I put in this, that's not less than or equal to 9. But since I don't check it until here, that would add 1 to it, and it would print out 1112. All right. And also look on the screen if you would. See that? This is the only time that after an if or a switch, you never put a semicolon. After a while or after a for, you never put a semicolon. But after a do while, with the while part, you must put in a semicolon. It's just the way that it's set up. All right. Then the last type is what's called a for loop. A for loop is also known as a counting loop. With a for loop, you need to know exactly how many times you're going through it. Because it says here, start at 1, and as long as it's less than or equal to 10, do this, then add 1 to it. So all 3 of these, when you look at them, they all, for lack of better words, they simply all count from 1 to 10. That's what all 3 of them do. All right? So again, if I run this, hopefully I didn't screw it up. There's 1 to 10 with a while loop. There's 1 to 10 with a do while loop. There's 1 to 10 with a for loop. What I'd like you to do, not this second, but I'd like you to look at that code, and if you have questions, then you can ask tomorrow. All right? With that, I'm going to jump right into Chapter 5. Chapter 5 in your book starts on page 185. As you can see, it's called looping. I just showed you the while loop, the for loop, and the do loop. So we're very quickly just going to look at that. Then when we get to the nested loops, I want you to pull out that other page that I gave you. And then we'll talk about that. All right? And then we'll talk about accumulators, how you can improve loop performance, and some of the issues you have with loops in GUI programs. You don't have nearly the number of loops typically in a GUI program that you have in a console. And the reason is when you are running a GUI program, what you do next is typically going to be decided by the person running the program, not the person who wrote the program. So, as it says there, a loop is a structure that allows repeated execution of code. All right? Whatever that happens to be. Everything within the curly braces is called the loop body. Looping is also known as repetition. It's also known as iteration. Depends on the book you read. So there's the while loop. We just looked at it. You can use a while loop to execute a body of statements as long as what's in the parentheses remains true. So it's while a Boolean condition in the parentheses, and you've got some code. If you never change the value, you don't have to look, but please listen to this. If you never change the value of the loop control variable inside of the curly braces, you have what's called an infinite loop. That's a loop that will run forever. Sometimes you actually want that in programming code. If you've got a product that runs 24/7, 365 days a year, you very well could put it into an infinite loop. All right? So they give you some examples. Are they better than mine? I don't know. I don't care. They show you how you can get an infinite loop there on page 187. Typically, not always, but typically, when you get an infinite loop, you made a mistake. Not always, but typically. All right. It says to make a while loop and end correctly, you need 3 things to occur. The loop control variable must be initialized, it must be tested, and it must be changed so you can eventually fall out. Okay. She goes nuts here with the flowcharts. I think I could have saved 100 pages off this book by not adding the flowcharts like she did. charts. All right. If you write a loop, and if you look on the screen here, if you write a loop and you put nothing in there, you may want to do that. All right. That's a loop with an empty body. It'd be something more advanced programmers would do. It's not that you can't do it, but the chances of you wanting to do that are not good. All right. When you change the value of the loop control variable, you alter it. All right. If you look up on the screen here, please, because it just made me think of it right now. I don't want that. I want this back. All right. Can somebody tell me if I'd have done this? Okay, I've got the while loop here. Now I'm going to change this to while LCV is less than 100. Okay? In fact, let's say less than or equal to 100. Oops. Sheesh. All right, so I'd said here less than or equal to 100. And instead of saying plus LCV here, I said LCV plus equal 10. Can anybody take a guess as to what that's going to print out? How about 10, 20, 30, 40, 50, 60, 70, 80, 90, 100? Let's see if I'm right. I could be wrong. And there you got it. I guess it went up to 110. So instead of saying less than or equal to, I should have just said less than. And that should print out 10, 20, 30, 40, 50, all the way to 100. And it does. So what I'm telling you is the value of this loop control variable, most often it gets changed by 1, but it doesn't have to be. So what you should be able to do, what each and every one of you should be able to do, is to figure out, for example, how to write, well, I mean, simply, you should be able to write any of the stuff that's in here. And you should be able to say, well, what if I wanted to print all of the odd numbers that are between 1 and 100? All right, you would just change this. You'd start at 1, and you'd tell it to add 2 every time. That's it. They talk about a definite loop and an indefinite loop. With a definite loop, you know how many times the loop is running. With an indefinite loop, you don't. I just showed you 3 loops: a while loop, a do while loop, and a for loop. The for loop is called a counting loop. You cannot use a for loop for this, for an indefinite loop. It must be definite. You must know exactly how many times you're going through it. If you want to, if in one of the programs I think that you're doing for Chapter 5, it tells you to keep reading in integers until somebody enters a 999. That's your stop value. All right? That stop value is often referred to as a Sentinel value. You know what a Sentinel is? You know, like a person in the military, Hall 2 goes there. It's the same kind of an idea. But the Sentinel value says that when you input that, get out. Again, when we go through this, if you're having problems, there's a good you do it exercise that's on pages 193, 194. All right. The for loop, again, is a counting loop. You do the loop initializing, the loop testing, and the updating all in one line. Any loop that's written as a for loop can always be written as a while or a do while. The reverse is not true. So there's some examples of writing a for loop right there on page 196. All right. If you look up on the screen, please, because there's something they mentioned here that I forgot to tell you. All right. If I were to do this, and if you don't look, eventually it's going to bite you. But I'm going to make a new variable here that I'm going to call LCV2. Right there and right there. All right? So I've got this for, I got to make sure I let the system know it's an int. All right? If I come in here and right here I print out right line, LCV2, okay? See how it's red? Everybody see that? It's like, well, what's wrong with that? Anytime you create something like this, it's only visible within the curly braces. Once I fall out, this doesn't know what it means. That's why when I first did it, and I had just LCV right here, and then I don't need this line. The reason is I defined it way up here. Then I could use it all over the place. But if you define something within curly braces, or right up above it, in a loop block, it's only known within that block. It's not known before the block or outside of the block. You want to read that, it's on 196. They call it being in and out of scope, but the idea is exactly what I told you. All right, the do while, again, the do, whereas the while loop and the for loop are pretest, meaning, again, if the initial condition is false, you don't go through the body. A do while loop is post-test. You always go through it once. Sometimes what programmers do is they write all their loops as a do while when they're going to test them, because then they always run. Then once they're sure they work, they may change them around to a for loop or a while loop. All right? There's the pretest and post-test. If you didn't like my verbiage or you didn't understand it, it's on page 200. Loops are one of the more powerful things that you have available to you. All right. Next, they talk about nested loops, and they go through this tipping table that's on pages 203, 204, 205. All right. And they show you your bill and what would it be if you could get left at 10%, 15%, 20%, etc. Now, if you would please, because I'm almost finished, if you would bring up that other piece of paper that I gave you. And that is the one, I believe it's called Loop Fun. You may not think it's fun, but what I want you to get out of this is I want you to look right here. Lines 20 through 34, because this is where all the magic takes place. All right? This is simulating a clock. I'm going to run it for you in a second. The first time through, hours is 0, minutes is 0, seconds is 0. So in other words, what we'll print out is 0, 0, 0, 0, 0, 0. Does that make sense? All right. Then you get down to the bottom of this inner loop here, and that's what you print out. Then it comes back up to this loop, and it says, are the seconds less than 60? No. So now it does 0, 0, 0, 0, 0, 1. Okay? And it does that until it gets all the way to 0, 0, 0, 0, 59. Then this test fails, so it goes back up to this one. So then it goes 0, 0, 0, 1, 0, 0. And it does that, and it keeps doing that. Eventually it gets down to 0, 0, 59, 59, and next it'll go 0, 1, 0, 0, 0, 0. Just like a clock would go. All right, and that's exactly what this program does. I don't remember, I think it's 86,400 seconds in a day. I could be wrong, but whatever it is, 60 times 24. All right, but you'll notice if I run this, there it goes. And it runs in less than a minute. It does the processing that fast, but it's the output that slows it down.
Is there a way to simulate it, like a second?
Oh, if you wanted to stop yes, you can work with. There's actually a control in the toolbox called a timer. And you can do that. You could set a timer so you could have it literally be a clock where it would tick, 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 and every 1 second it would change if you wanted to do that, yeah. I mean, it wouldn't be hard at all. Notice, but right here I'm up to, it's 2 o'clock in the morning basically. All right, but I ran it and it actually took less than a minute to go through the whole thing. And you can click right there and stop it at any time, and then you can go back and look at the logic, hit it again, and it, I think, well, maybe, yeah, it starts right back up again. If you want to stop it, you just click here. But what I'm concerned with is that you understand this loop is in this loop is in this loop. So we've got a nested loop within a nested loop. So this is going to run 59 times. Once it gets to the 60th time, that's going to go off. That's going to go 59 times. Once that goes up, then that's going to go. And that's going to go 24 times. If you understand that, there's really not any more to understand about it. I did put this little thing on the end, which said that if the number was greater than 9, print it out, otherwise prefix it with a 0. Otherwise, it looks really ugly. So if it's like 101 with 1 second, if you don't put in this function, it prints 1:1:1, which just looks kind of ugly, as opposed to 01:01:01. All right. So again, there's this tipping thing. Finally, they talk about accumulators in here. This is on page 206. All right. An accumulator, what an accumulator is it's not a counter. What we looked at before with that LCV, those were counters. We're not talking about a counter here. We're talking about an accumulator. So if I say, okay, I gave a test, and everybody in the test who took this test got 100. There's 13 of you. The accumulator for total points would be 1,300. Does that make sense? Then the accumulator for total students would be 10. So if I divided total test points by total students, I could get the average. All right, that's exactly what they're talking about here on page 208, it looks like. All right. Then finally, they talk about how you can improve, it's 206, not 208, how you can improve loop performance. Okay. Before we go into this, I just want to show you something because I want you to know this. All right, let's see, where are we? We're on this one that we just looked at here. Of course, I closed it. On that clock. And these are just things I want you to at least see. Are you going to remember them? I don't know. Am I going to take off if you don't do them? No, but I want you to see this. All right, so I'll go into Loop Fun. I think it was the clock one. Should have just called it clock. All right. Bless you. Does everybody see this loop right here? See this? That says add 1 to hours. Does that make sense? All right. If I'm running through this a million times or a billion times, doing this runs faster than doing that. It just runs faster if you pre-increment as opposed to post-increment. All right? That's one way that you can save time. Oops. Another thing, just so you know, this is initializing a variable, testing a variable, all right, and incrementing a variable. If I'm going through this loop a million times, anybody want to guess how many times that runs? It's not a million. Once. We initialize it once. This runs a million times. That's my test. This runs a million times. Do not in here put in a calculation. If you put a calculation in there, that calculation will run a million times. Do the calculation outside of the loop and then use it inside of the loop. That's another way that you can save a lot of time. It's amazing when you go and you look at a lot of code that's out there, just how bad it is. All right, I've written my share of bad code that's actually out there in production right now. So that's what they're saying. They're doing it in a while loop. But they say, rather than putting in this, while x is less than a plus b, where it's got to figure it out every time, instead, figure out a plus b, and then it doesn't have to do the calculation. It sounds simple, but it saves time. Consider the order of short circuit. I've talked to you about this before, and I'm going to say it, and hopefully this will be the last time I ever say it. All right. Imagine that we're a four-year school. So we've got freshmen, sophomores, juniors, and we've got seniors. Everybody, I think, gets that. All right. If I'm going to write a statement that says if class equals, let's just assume that 50% of my students are freshmen, 20, 20, and 10. Okay? Would you agree if I got 10 people, the chances would be best that most of them would be freshmen? Does that make sense? All right. So if I'm checking for an or where only one has to be true, I should check first for freshmen there. All right. And if it's an or, typically you'll want to check that first. And that's what they're saying with their order of operations. All right. They go through it, and she gives a very good explanation here on page 209. I think it goes on to the next page. Yeah, right to the top. Loop fusion says if you have to, you can combine loops together using the prefix. This is what I already showed you. Do the plus plus at the beginning of the loop control variable and not at the end. All right. As far as issues that you have with using looping in GUI programs, you might use looping in GUI programs, but you typically don't use a lot of it. And that's what she says in here. So if you would please turn up to page 217. Let's quickly go over these review questions. All right.